One.
Hi, I am Ms. Sabatello. I teach accelerated chemistry at Maine East High School. We are in Unit 2 of the modeling curriculum, Energy and Particles in Motion, otherwise known as gases. I am here to teach you how to use proportional reasoning to calculate pressure, volume, or temperature when P, V, and T change. Note that this presentation only involves solving for the final values. Prior to solving this type of problem, my students have already done the following. The students have investigated the relationship between P and V, P and T, and V and T using labs and simulations. My students have predicted if one variable increases or decreases, if the other variable increases or decreases. My students have solved problems by setting up ratios or proportions based on the predictions. This replaces algorithmic problem solving where students memorize and plug and chug. So here we have a problem where a gas takes up a volume of 17 liters and has a pressure of 2.3 atmospheres and a temperature of 299 Kelvin. If I raise the temperature to 350 Kelvin and lower the pressure to 1.5 atmosphere, what is the new volume of the gas? So step 1 is to identify the find, what you are looking for. So you'll start the problem with the known that has the same unit. We're trying to find volume, so we will start with liters. The next step is to predict the changes in volume that will occur, increase or decrease, by observing if P and T increase or decrease. So in the problem, the pressure decreases from 2.3 atmospheres to 1.5 atmospheres, so volume will increase. Pressure and volume are inversely related. Temperature increases from 299 Kelvin to 350 Kelvin, so the volume will increase, since volume and temperature are directly related. In our workbooks, we have set up this chart for students to complete. We put in the initial values from the problem into the table. We put the final values for the problem into the table, placing a question mark for what we're trying to solve for. In the effect column, I include also predictions for the missing variable. What does that mean? Well, we can see that pressure from the initial to the final conditions decreases. So I write decrease in the effect column. We can also see from initial to final that the temperature increases. Here in the middle row is where I include a prediction for my missing variable volume. We know that the decrease in pressure causes volume to increase. Also, the increase in temperature causes the volume to increase. Down below, we see an explanation of our calculation. Remember, we start with volume since we're solving for volume, 17 liters. We arrange the pressure ratio to increase the volume. So I put the big number over the small number. I arrange the temperature ratio to increase the volume. Again, the big number over the small number, and I get my answer of 31 liters. To summarize that problem, once again, we wanted to find volume, so I started with volume, 17 liters given in the problem. My pressure decreased throughout the problem, so I arrange the pressure proportion such that it will make the volume increase, since I know the relationship between P and V is inverse. Also, I arrange the temperature proportion such that it causes the volume to increase as well. And I've placed the bigger temperature over the smaller one. And notice the units of atmospheres cancel, kelvins cancel, and we end up with liters. Let's try another problem. A scuba diver below the ocean inhales 50 milliliters of compressed air in a scuba tank at a pressure of 3.00 atmospheres and a temperature of 8 degrees Celsius. What is the pressure of the lungs if the gas expands to 150.0 milliliters at a body temperature of 37 degrees Celsius? Once again, we identify the find that is what we are looking for. You start the problem with a known that has the same unit. Our answer here is atmospheres, since we're trying to find the pressure. We'll start with the pressure. Step 2, we're going to predict the changes in pressure that will occur, increase or decrease, by observing if V and T increase or decrease. So we can see from the problem the volume increases from 50 milliliters to 150 milliliters, which will cause the pressure to decrease. The temperature increases also in the problem from 8 degrees C to 37 degrees C, which will cause the pressure also to increase. So we arrange the volume proportion such that a decrease in pressure will occur. Notice I've placed 150 milliliters, the bigger number, in the bottom of the volume proportion. I also arrange the temperature proportion such that an increase in pressure will occur. That's the top number over the bottom number, and the top number is the bigger number. Don't forget to convert degrees Celsius temperature to Kelvin temperature by adding 273. And I already said that. So to summarize, the students have learned how to use proportional reasoning to solve combined gas law problems. This replaces the traditional method of plugging and chugging into that equation, P1V1 over T1 is P2V2 over T2. I have found my students have more mathematical reasoning skills by using this method rather than plugging and chugging into an equation using algorithmic problem solving. I hope this helps you to understand how to use proportional reasoning to solve combined gas law problems. Thank you for watching.